Hello, welcome to another video. In this video, we're going to do two lectures in one that kind of go over the context for the scientific revolution in European history and some of the parts of the scientific revolution that encapsulated the astronomical revolution. So, familiar friends like Galileo, Isaac Newton, people like that. So, we're going to look at them today and see kind of where this idea of the scientific revolution came from and what some of the uh, big names were that kind of came along at the beginning of this movement. So, like any part in AP Euro, we're going to look at context. What's setting the stage for this movement. Going back to ancient Greece, ancient Rome, the classical period of European history, there are lots of examples of philosophers from Greece and Rome, particularly Greece, that really inspired some of the first scientists in this course. Um, we're going to see, lots of ancient knowledge kind of go away after the fall of Rome. And then that knowledge is going to spread throughout North Africa and the Middle East, where Muslim empires are going to keep that knowledge alive. And slowly but surely, that knowledge is going to make its way back into Europe as the Renaissance takes place, as scientists get more curious, and as just the dissemination of knowledge begins to kind of bring that knowledge back into Europe. So, who are some of these people that the ancients knew really well? So we have Galen. He was a predecessor and a big source of knowledge in the medical field. So the fields of anatomy, physiology, pathology, pharmacology, anything to do with medicine, treatment for disease, and things like that. He lived, at the time of the Roman Empire, so 129 to 216 CE, somewhere in there. And his big medical knowledge stayed dominant for centuries, like a lot of these, like the knowledge of a lot of these guys did. His big theory was about the humors that in the body, the human body, um, you have four humors, four types of liquidy, gassy types of things that exist in your body. And those humors are black bile, yellow bile, blood, and phlegm. Um, if your humors are off balance, if there's an issue, that's what causes you to get sick. So if you're missing some black bile, that could throw off your system's balance, leading you to get ill. And again, he's pretty dominant for 1,300 years. We know today, that's not necessarily true. Um, we might have bile or blood or phlegm in our body. We always have blood, right? But just because there's like a quote unquote off balance does not mean anything. This is why you might have seen leeches used, like in movies or TV shows, to show medical treatment, because they were medical treatment. People thought that they would get your humors and your liquids in your body back on track. Aristotle, probably the most famous out of these predecessors. Again, he lived in ancient Greece, a student to Plato, who was a student to Socrates. So in that chain of Greek philosophers, he is the most known by many Europeans. You can even find peasants here and there that were on the more educated side. They might know who Aristotle was in this period of early modern European history. Um, he was a really big name when it came to the study of the cosmos, of the universe. He believed in a geocentric universe, that the Earth was the center of the universe, and that all of the planets flew around the Earth, circled Earth in a perfect circle, in perfect unison, and were made out of crystal. He believed the Earth was made out of four elements, which is earth, air, fire, and water. And that the heavens above, where God and all the angels and stuff were looking down, that was made up of the fifth element, aether. Again, just like Galen, he was around for 1,300 plus years. And today, you still learn about Aristotle in some of your history courses and things like that. So, again, an incredibly influential character. Another really important person, a scientific predecessor, would be Ptolemy. I did briefly mention him when we talked about the context for the Age of Exploration. He was a big geographer. He supported Aristotle's idea of a geocentric universe. kind of built upon that a bit. But he was also influential in the world of exploration. He built up the idea of geography, the study of geography, and people kind of went along with that and kind of, again, followed his model like they did Aristotle. So these are some of the big names that really influenced early European science. They are lost when the Western Roman Empire falls. You could argue they stayed intact in, Constantinople and parts of the Eastern Roman Empire, but they're really kept alive and pushed forward by Muslim empires, by the Islamic caliphates, by the Ottoman Empire. They kept science alive, and they are kind of, in this part of the world, Europe, North Africa, the Middle East, those empires really keep science alive for the most part, and they push it forward, coming up with inventions and discoveries around, geometry, algebra, and things like that. They really, once Rome falls, in 476 or whatever, we really do see the Islamic world really advance scientifically in a major way. What we see in Europe at this time is a retreat after Rome falls and Europe goes into its quote dark ages. We see Europe retreat into a period of mysticism and magical nature, where you have quote scientists working in what we would consider today to be non-scientific fields, but back then it was all one and the same. Studying the stars and studying the way stars and planets move was the same as trying to turn materials into gold, or a belief that these stars can have an impact on your life and maybe tell your future or something like that. These fields, astrology, alchemy, kind of fall into this field of Hermeticism, which again is a belief in magic, and then that natural elements and natural objects have magic, and then through experimentation and magic, you can bring those mystical properties forward. While we know this isn't true today, it's important to note that people who experimented with alchemy or observed stars in an astrological sense by trying to study astrology, they did practice some scientific methods, at least early scientific methods. Again, empiricism, observation, experimentation, all that stuff is going on with some of these things. What are some other influences for the beginning and the context for the scientific revolution? Of course, you can't not mention the Renaissance. The Renaissance in Italy and across Europe really brought back some of these classical sources, not just Cicero, but Aristotle, Ptolemy, Galen. They all came forward, and when a new piece of writing was discovered from Cicero, you have some writings from Aristotle and some early ancient scientists come forward too that really inspired Europe. The printing press, of course, was incredibly influential. It allowed scientists to print out their treatises and their discoveries and spread them across Europe. You have the Reformation in a minor way, kind of opening up some of the foothold that the Catholic Church had on some of these ideas. Not to say that the Protestant churches were more open towards science. That's not always true. But this idea, again, that you could challenge the church in some ways did allow some of these scientific ideas to move forward. Again, Muslim scholars had been at work for centuries while Europe was, toiling and fighting each other in the Dark Ages. So you can't ignore their contributions and things like that. But you do have, again, this rich culmination of the Renaissance and outside forces moving into Europe that really brought some of these scientific things forward. Last point on this here is that we do see science kind of fall into this field of philosophy. In this period, which we're going to start like in the late 1400s at the time of the Renaissance, all these ideas of science, whether it's medicine, astronomy, astrology, which isn't, scientific, but back then it was, they all fall into the idea of philosophy. They were maybe called natural philosophy, but philosophy, the philosophy of Socrates, Plato, etc., encapsulated science and mathematics and all these other studies and things that were going on. So things have shifted a little bit, but that's kind of a big important thing to note here anyway. If you want to see kind of what Aristotle type philosophers, ancient philosophers, kind of thought about the universe. Here's a nice summary of it. You can pause it and read it, but that's kind of what Aristotle and some of those other ancient philosophers kind of believed in when it comes to the universe. All right, our next presentation's on when the scientific revolution started and how it started with some of the scientists of the early scientific revolution in the 1400s and beyond. So the first person you may know a lot of these names, but you might know him especially is Nicholas Copernicus. Again, this lecture goes back to the beginning of the course, really. While he's working in Poland and in Italy, the Renaissance is crossing across Europe. The Reformation's beginning in 1517. So, this unit does kind of start back when the course started, a couple units ago. Anyway, Copernicus, he first studied in Poland and then he moved to Italy. He apparently has a really interesting and cool lab in Krakow, if you ever get the chance to go there. I have not been, but I've heard good things about it. He is one of the first scientists to challenge Ptolemy and Aristotle and their idea of a geocentric universe. The Copernican model is a heliocentric model. Basically, again, restating this, a geocentric model, which existed by people like Aristotle and Ptolemy, they stated that the Earth was at the center of the universe, and the suns, moons, and planets all went around the Earth. In Copernicus's model, he stated that actually the sun was at the center of the universe, and then all the planets and other things in our galaxy went around the sun. He tried to use some sort of basic mathematics and observation to state this, and he said it was more accurate based on everything else. He writes this during his life, and he does not publish it. He sits on it for a while. He realizes, and he saw this with his own eyes, that if he were to publish it, he'd probably get criticized and maybe persecuted by the Catholic Church. The Inquisition's going on. There's religious persecution of people that challenge the church. And to put this forward would go against church teachings. At the time, the Catholic Church was very supportive of the idea of a geocentric model because they believed it was stated in the Bible. In their Bible, it said that all of the planets went around the Earth and the sun went around the Earth. So to challenge that idea would challenge the Catholic Church. And Copernicus was not willing to do so. Nevertheless, at the end of his life, he does publish it, and he dedicates this work to the Pope. With him not being alive to really defend it and publicize it too much, it's not really a big impact. So he kind of gets ignored for the most part. There were some scientists, though, in this burgeoning scientific community, though, that did latch onto his writings. One of those being Tycho Brahe. Tycho Brahe worked in Denmark and then later in the Holy Roman Empire in, I want to say Eastern Europe, maybe Poland. Not too sure. You definitely don't need to know. But Tycho was an interesting guy. He's often pictured with a gold nose because he lost his nose in a duel, I believe. But Tycho was known for his expansion of Nicholas Copernicus's work. He didn't like the Copernican model, the heliocentric model, but he definitely didn't like the Ptolemaic or the model of Aristotle that had Earth at the center of the universe with everything going around the planet Earth. So he had his own model, which was not very popular as well. But he did see the merits of Copernicus's work. He did see the observation math that went into Copernicus' work, and he did expand upon it. In addition to being an astronomer, an early astronomer, he also studied astrology. It's really hard to find someone who is an astronomer and not an astrologer at this time. They kind of go hand in hand, even though today one's a scientific study, astrology is not. But we do see him, kind of work for monarchs and leaders of Europe at this time to kind of tell their future and tell their fortune and things like that. He does put a lot of work into astronomy and the study of astronomy. He used mathematics to kind of make charts and calculations of planetary movements. And he did all this work without the telescope, which is interesting. Probably the most important pre-telescope astronomer in Europe. He does have a student that kind of follows in his footsteps, and that man's name is Johann Kepler. He kind of expands on Tycho's work, and he combines astrology and math in a more stable way. He stated, which is going to be expanded upon by future astronomers, that the universe as we know it not only was heliocentric, as Copernicus said, but it was based on geometric principles, on math. This is going to kind of set the stage for people like Isaac Newton, that said, the entire universe runs on the same mathematic principles, whether it's, a speck of dust falling to the ground, or if it's a comet shooting through the stars, everything runs on the same set of mathematic principles, which we know is, mostly true today. But, back then that would be, unheard of. But Johann Kepler's going to kind of set the stage for that. While he isn't heliocentrist, he still has some disagreements with Copernicus's theory, of these planets going in perfect circles around the sun. He says the planets actually move in ellipticals because the planets are going around the sun at different speeds, and as we know today, years on the different planets are different. So he kind of came up with that idea as well to an extent. By the end of his life in the 1600s, we're starting to see the idea of a Aristotelian or Ptolemaic universe fading away. Finally, we get to the big guy, Galileo Galilei, Italian astronomer. He was at first a math teacher in Pisa in Italy, living in Italy at the time of the height of the Italian Renaissance, but also at the height of the power of the Catholic Church, right before the Protestant Reformation starts to slowly chip away at it. He is the first European to use a telescope. The telescope was invented in different places, but as far as Europe goes, Galileo was maybe the first to use it and to make observations with it in a standard scientific way. He observed the craters and mountains on the moons around Jupiter, and sunspots in the phases of Venus, where you have Venus, kind of looking different because the light of the sun is shining off of it. He also had an interesting idea that we kind of know is relatively true today, that all of the materials in the sky are not made of aether, some of this fifth element type of material, but rather stuff that's similar to what you could find on Earth. So stating that that the galaxy is all one component, kind of getting to this idea of a standard universe across the board. One of his first major works was The Starry Messenger, in which he discussed the ideas of astronomy, including things in the sky, moons of Jupiter, and things that he observed in time. He is a heliocentrist. He supports Copernicus's idea of heliocentrism, but he is not the biggest supporter. He knows that he lives in Italy. He knows that the Catholic Church is still incredibly powerful and that they do not support a heliocentric model. And in fact, they have executed scientists very recently who did support a heliocentric model. So he is very wary of this, and he takes great care, or at times he takes great care to really avoid challenging the Catholic Church directly. He has a different view than the Catholic Church. Again, the Catholic Church is so against heliocentrism because they think it goes against the Scripture and the teachings of the Catholic Church. Galileo, while a strong Catholic, he said, I don't look to the Bible to find scientific knowledge and information. I look to the Bible to, reaffirm my faith and belief in God and Jesus Christ, our Savior. So I'm not going to, say that anything part of the Bible is wrong. I'm just saying that, science isn't really necessarily the main reason why I read the Bible. And I'm not going to look to that, what's in the Bible to, support my scientific knowledge. Nevertheless, he is not really taken seriously by the church when he says that. However, he avoids persecution by the Roman Inquisition for a time. the Catholic Church, and still has the Inquisition going on, where they pull people forward and attack them and accuse them of heresy for going against their teaching. He receives a patronage from the de Medici family, just like a bunch of artists that we studied in Unit 1 did. So he is still relatively supported. He gets a warning from the church that if he keeps going down this path of studying science and putting forward scientific theories that challenge the Catholic Church, he will get attacked and criticized. But he more or less ignores these. In 1632, he publishes a major work, a dialogue on the two chief world systems, the Ptolemaic model and the Copernican model, which again, the Ptolemaic/Aristotle model is a geocentric model, and the Copernican model is a heliocentric model. It's written in the vernacular, which is interesting, so maybe a slight jab at the Catholic Church. But again, this is directed towards the Italian community, the people of Italy, the scientists of Italy, the thinkers of Italy, the Renaissance writers of Italy, the ones that didn't like Latin as much anyway. Many of them did like Latin. But we see here that he is putting forward, again, this model that the heliocentric model is a scientific fact, that the Catholic Church is wrong, and that he is correct. So the next year, he is finally dragged before the Pope. He is dragged in front of the Inquisition, and he's accused and convicted of heresy. And he's forced to spend the rest of his days in house arrest for his work to challenge the Catholic Church and to support a heliocentric model. He lives for about 8 more years and dies in the 1640s. Again, Europe's going through the 30 Years' War, but he is dealing with this as well. His work is banned across Italy, and where the Catholic Church had power, because they didn't have power across all of Italy, because it's still not organized, and his career is pretty much over. He eventually goes blind, develops insomnia and hernias and things like that. So it's kind of an awful way that this brilliant scientist really had his life ended. There's some rumors that, right before he passed away, he said, "But it moves," or as he walked away from the Inquisition, he maybe said that. Potentially that could have been true. I personally, I highly doubt that he stopped believing in these scientific facts. He's a scientific guy. He just had to say what he had to say in order to survive, and it did save his life for 8 more years. Other things that he kind of worked on was the ideas around inertia and motion. There's the story of him maybe dropping objects out of the Leaning Tower of Pisa. That may or may not be true. There's no evidence that it actually happened. It was maybe just like a thought experiment. But he does come up with some discoveries and things like that around motion and the use of, kind of some early engineering type of ideas that were also influential. And again, this is before the Inquisition, kind of ended his career. The last scientist for today is by far the most impactful in European history and world history. If you look at the most influential people in the history of the world, he usually is near the top, even though he's not like, a figure like Napoleon or, another military person. Isaac Newton did so much more than any other scientist to really push forward these scientific ideas. And luckily he was living in an environment that was receptive of a lot of his ideas. Very interesting person, very neurotic in a sense. He went to Cambridge University and studied philosophy and then alchemy and mathematics under that philosophy umbrella. He did things like invent calculus, which we'll look at. He wrote Principia, which has a lot of knowledge and information about some of his major ideas around physics and movement and things like that. He was a master of the mint, a president of the London Royal Society, which are these new types of scientific institutions we're seeing come around in Europe, in places like England, France, etc., that are going to see, government supportive of science and push science forward. He was a member of Parliament, I believe, and he was knighted in 1705. So he had a big career, really important things that he did. He also relied on patronage and he got support from the government and from the powers that be, the nobility, etc., for his work. Let's look and see just some of the things that he did. So his big discovery, I guess, is twofold. The one you're probably aware of are his laws of motion. The three laws of motion are listed over here. The object in motion stays in motion unless it is deflected by a force. The rate of change of motion is proportional to the force acting on it, and then to every action there's an equal and opposite reaction. I'm sure you learned those in science class. I remember learning them in my science class. So it's a very standard thing to see. These ideas of motion kind of come around and create this idea of a Newtonian world machine, that everything in the universe, whether it's the tides, whether it's the stars in the sky, whether it's a falling object, whether it's a cannonball, whether it's a bullet coming from a gun, whether it's a broom being used by a shopkeeper to sweep dirt off the floor, everything in the universe, whether it's in space, on Earth, in the ocean, follows the same set of physical rules. That everything follows the same set of rules around motion, inertia, velocity, speed, etc. The idea of gravity, again, is a part of this as well. And everything is impacted by gravity and motion in the same way, just depending on their environment. This is the idea of the Newtonian world machine. And again, there is sometimes a belief that science is anti-religion. That's definitely not the case until more recent human history. In the 14, 15, 16, 1700s, some of the centuries we're looking at, these people are all incredibly religious. They believe in religion. They believe in the church. They just believe that God, the person that God is, set all of these scientific things in motion, put them forward, and let them kind of take place. That God invented gravity, for example. Now gravity is kind of fulfilling what God had in mind. So it's an incredibly impactful view of the universe. I can't really overstate just how important it was. And again, just the idea that everything follows the same set of rules is mind-changing, and it really wasn't accepted or understood, honestly, by too many scientists at the time. But today, it's still taught in schools, and it's still incredibly dominant in the world of science. We're going to see later scientists in the 1900s, early 1900s, really start to challenge this. That ideas that hey, maybe science isn't totally understood, and there's unexpected and random things that can happen and will happen. But for hundreds of years, Newton's science is incredibly dominant. Other discoveries and intellectual pursuits of Newton include the things listed over here. I'll just kind of read them off to you just to show you just how dominant of a scientific mind Newton was. The idea of lights and color, coming from primary lights, that three colors of light, red, green, and blue, can make all the other colors that we see when it comes to light. He calculated sound waves. He saw that light waves could be analyzed in a similar way. He correctly or very accurately calculated the average density of the Earth. He said that our nervous system, which no one really knew what that was at the time, he said that was powered by electrical messages, which is true. If you've taken psych, you know that action potential is in part electric. He began working in thermodynamics. His work was only understood by scientists 200 years later, in the 1800s, early 1900s. He constructed the first light reflecting telescope, and he began writing on theoretical physics. Some argue that. So again, just an incredibly impactful scientific mind around the laws of motion and gravity and things like that, and the idea that everything runs on the same set of mathematical principles. To show you just how things are changing, at the turn of the century, between the 16 and 1700s, as England is getting through the Glorious Revolution, that period, he publishes his major work, Principia, in Latin, and it's the last major work to be published in Latin. So at the beginning of this course, everything was in Latin pretty much. Now, with the spread of the printing press and the vernacular language and things like that, we're seeing that slowly shift away. And now, pretty much after Newton, everything is going to be published in the vernacular. So, while he is a big force in the field of science, he's also one of the last remaining forces in the Latin language and how impactful it was. All right, so that is this big lecture. It's really two lectures in one. Next time we'll look at some other advances in science and we'll go from there. See you next time.